to Mr. Dickinson, or Mr. Dickens, actually, I have endeavored in these mere 30 minutes of time with you to raise a powerful but hopefully affirming idea that I hope will not put any of my listeners or audience out of humor with themselves, with each other, with the content, or even more importantly, with me. May the ideas that are presented here ignite new thoughts, focus, and imagination, and may none of you leave here without at least a bit, just a bit, of wonder. So yesterday, Richard and Chris spoke with passion around how, I'll use the capital how, by our agile constructs, our new ways of teaming. We at HCL Digital Solutions are fundamentally changing the means via which we make our products, and that how, again, all caps on the how, will make a big difference in our products, features, and functions and speed to delivery. But what I want to talk to you about is not the how, but to complete what you heard yesterday from Richard and Chris, I want to talk about the what. What are we building? Not the list of functional elements or new features, but what it is that we're building. There's always been, and I suppose there always will be, conflict in the mind and heart of a software engineer. On one hand, they're highly trained and skilled engineers capable of doing amazing things, breathing function and purpose into, frankly, what is just a bunch of hardware with logic gates and transistors. But, and this is important, on the other hand, software engineers are frustrated artists, trying, in some cases desperately, to create elegance and grace in what is something very difficult to embrace their artistic passions, and that's software code. And unfortunately, right now, the art side of engineers, the art side of software engineers, the part that leads to that elegance, that simplicity, that grace, is not really shining through. But it can be done. You can create software that lasts, or software of the future. What you're seeing now is 6502 assembly code, perhaps one of the most, if code can be considered that way, famous code ever written. This was the second software language I actually learned at the age of 8, and even today, and it's terrifying to think this, I can still read it. The entire program is 254 bytes long, not kilobytes, not megabytes, bytes. Because the 25-year-old programmer of this code, this masterpiece, if I call it that, only had 256K bytes of ROM available. See, I'm saying it too. He was trying to build his own computer. It was his first computer at an era when no one could really buy computers. And so he didn't have any way to write down what you're seeing on the screen, other than in a notebook, on paper. The code you're seeing has some pretty unique functions for something so small. In microcomputers, there was no real function to be able to get code in and out of memory without flipping a bunch of toggle switches, sometimes hundreds of them, on the microcomputers of the day. But not with this computer, not with this code. With this code, for the first time ever on a microcomputer, you could actually buy it and own it in your home or office. When you typed on the keyboard, the character actually appeared on the screen. The programmer, as I told you, didn't own a computer, so he had no way to compile the code. And I kid you not, what he did was compile it in his head into ones and zeros, and then write them down in that same notebook. He had to go into HP, and he had a buddy who, at night, after the managers left, burnt the ROM for him from his paper-written compiled code, and it ran the first time. Steve Wozniak, other than being the co-founder of Apple and Apple's employee number one, knew how to build software with a future, software that lasts. The code I just showed you, you can still run it today. You can still compile it today. No libraries, no bloat, no dependencies that no one can find anymore. It left no waste, nothing unnecessary. It is fast. It is elegant. It does exactly what it is supposed to do and nothing else. And even today, if you fire up an Apple I computer and ask in the monitor program that Steve created, the code you just saw, for the content and memory location, like I just did, you get it. As an aside, the code I showed you before, that monitor program, as he called it, powered the Apple I. Apple I's today, by the way, are extremely rare, almost absurdly so for something created in the mid-'70s. There are only 63 known to exist. Of those 63, only 6 are in working order. This makes them very valuable. In fact, in January of this year, one of them was listed on eBay for $1.75 million US dollars. But you did get free shipping. So what happened to us? What happened to software engineers? How did we get from Steve's epic and elegant code to a place where code just a few years ago won't even compile? Libraries are scaled upon libraries and combined with even more dependencies. I can actually recall a moment in IBM, it wasn't a good moment either, where I could literally not figure out how to build a portion of a product because there were missing dependencies and I had no idea what they were or where they were. And lest I forget, this was in a shipping supported product. Scary. How did this happen to us? Well, actually, I can show you how this happened to us. This is one of my favorite theory models in computer science. It's even got a cool sounding name, the added complexity cycle. It's actually a real thing, and there's a great deal of research, academic research, around this model. Let me walk you through it. You start here. You've got a lot of bloat and technical debt in your product. And your product is struggling, right? And you've got to deal with this. You're walking in and you're trying to figure out, okay, we've got a lot of bloat, we've got a lot of technical debt. And this results in the inability of you to execute quickly. You can't keep up with your competitors. You just can't move fast enough. You can't add new features and functions to what you have to be able to get there because of your bloat and technical debt. So what do? Well, let's add a layer of abstraction, right? The joke in computer science is every problem can be solved with a layer of abstraction. Well, that's what you do, right? We add new libraries on top of the old code. We even don't have people that know the old code, but it's okay. We're going to add this new layer of abstraction on top of it. It'll get us away from our debt. We'll be able to move faster. This has got to help us, right? Do you know what? For a little while, it does help you. It does allow you to go faster. It does allow you to do new things. But there's a catch. Once you can go faster and do more things, there's more demand on creating new functionality, new capabilities. And so the maintenance of those libraries that you had added to put a layer of abstraction on top of your existing bloat and technical debt isn't maintained. You don't contribute back if those libraries are open source. If they're internal source, you don't maintain them. You don't evolve them. They get stuck where they are today. And then we find something new. Oh my gosh, there's this new cool thing. It's so exciting. It's a bright, shiny object. We can go chase it. We can scream in the mountaintops. Look, we're using black, and we're using green, and we're using orange, and it's so cool. Let's adopt that. Yeah, that'll surely solve our problems. And we bring all these new technologies in. In some cases, technologies that we don't need, actually, in most cases, technologies we don't need. And then we're frustrated because we haven't solved all the problems we originally had. We've created a new layer of abstraction on top of what we had, and we didn't even maintain that. And we've increased the number of defects in our product. We've caused support issues with our customers, etc. This is the added complexity cycle. And you go around and around and around. I used to work at Disney, and one of my first jobs there, I was a jungle skipper on the Jungle Cruise ride. It's a 10-minute ride, and I used to have to make up jokes at the end of the ride because there was often a backup for unloading the guests at the dock because there was another boat there. And one of the jokes I used to use was, ladies and gentlemen, I like this ride so much, I'm going to go around again and again and again and again. And that joke always really got people to laugh, but it's true. We are here. We at HCL, we can't move fast enough. Try as we might, push as we do, work hard as we do, we're stuck here. And myself, Richard, Chris, Andrew, Karen, David, Andre, Barry, all of the engineering leads, we are bound and determined that we are not taking another ride around this circle. We're done. It ends here. We're not going to do this again. Because we know full well what the consequences are of the complexity cycle. On the left of your screen, you're seeing the installation guide for the HCL Connections Component Pack 6.5 CR1. And it keeps going and going and going. and going. And here's how you configure this, and here's how you do this. And here, write some JSON, and here, write some XML. Wow, this is great. Keeps going, keeps going. Let's not forget, this is part 6 of the guide. This isn't even the whole guide. This is what the complexity cycle does. It makes everything harder, tedious, slow. It creates complex upgrades, painful deployments. It stifles innovation while it's seeming to encourage it. It's not. And we end up with this. There's 2 products listed at the top here. Notes 7 and Notes 11. Both great products. They can both open Domino applications. They both provide access to Domino email and calendaring. It's fantastic, right? But the one on the right is 203 megabytes, all in. And Domino 11, Notes 11, 1.07 gigabytes. That is a 5x increase in complexity. This is the complexity cycle at its finest. More libraries, more bloat, more focus on what is cool, and far, far less on what users actually need and want in the product. And I'm not just going to blame us. It's everyone else too. Windows 10 is at minimum 4.6 gigabytes just to install it. Windows XP, even the 64-bit version that can almost run all the same things, is 251 megabytes all in. Why? For all the same reasons I just described to you. Shiny objects, not focusing on technical debt, not writing elegant code, not simplifying. So probably many of you at this point may think this is a dystopian reality that I've just presented. One that's just going to continue to drag all the products and features, all the things that we love about these products down. But I'll tell you, where others might feel despair, I see hope. I see hope and opportunity. See, every major software vendor today is stuck in the added complexity cycle in one way or another. Some are where we are, some are in other parts of that cycle. And I can't think of a major vendor that is not stuck. But what if we could be the first to escape? Hypothetically, we could run rings around our competitors, right? We could not only be faster to value, easier to deploy, migrate, upgrade, manage, all of those things would be solved. And some people might say, you know what? I'm being too much of a dreamer. That this just isn't possible. You can't do that, Jason. We can't get back to something as simple and as elegant and as clean as Steve Wozniak's code from 1975. But I disagree. I think we can. On Tuesday, we released the VoltMX Lotus Script Toolkit. We open sourced it. It's on GitHub. You can go get it right now. At its core, it's 21K. That's it. And it does a whole host of things. But it's clean. It's simple. Go look at the code. Go look at it. It's well constructed. It's simple. It's elegant. It does exactly what it's supposed to do and nothing more. We can make elegant code with the future. And here's how we're going to do it. These are the things that we are going to do to get there. More importantly, these are the things that we are measuring our software engineers, our architects, and ourselves on. First one is libraries. Now, I've talked an awful lot about libraries. These are great things, right? There's little functions here, little functions there, and you don't have to write them organically within the product, right? You can go and adopt an open source library, an inner source library, a feature from another product, an HCL. They're great. They're wonderful. But if you adopt the library and don't maintain it, don't upgrade it, don't keep up with the functions and features, don't contribute back if it's an open source project, don't bring back in your patches, your fixes, you're not going to get anywhere. All you're doing is adding more debt on your own product. So we, going forward, if we do not bake in or cannot bake in the cost of maintaining that library, the cost of contributing back, then we will not adopt it. We will not do it. Elegance, building code that lasts, right? Elegant code always lasts, right? What does complex code do? It just creates debt, long-lasting defects. We're going to get back to really looking at the code we're writing and making sure it's elegant. Shiny objects. Yeah, let's get these things. This is going to be awesome. Let's go adopt this widget, gadget, block, flake, whatever it is. They're false hope. Adopting new technologies should be done in a way that is measured and reasonable. We need to be prudent about what we bring into our products. It doesn't mean that we're going to be old-fashioned. It means we're going to adopt the right technologies for the right things, for the functions we need to build great products for our customers and partners. And that takes me to simplicity. I spent a month once at Apple working on a project, a co-project between IBM and Apple. And one of the interesting things I found out about them was that every quarter they have a 2-week sprint for every product they make. And in 2 weeks, all they do is remove things. All they do is refactor code, reduce line numbers, move things around, reduce even capabilities in some cases. And that's what we're going to be doing. We're going to start refactoring. We're going to start simplifying. We're going to deliver the same value, the same functionality, but we're going to do it in ways that are much simpler, much easier to use, and for us, much easier to build upon. And lastly, art. Look, programming's art. And we've lost touch of that. We've lost focus in creating beautiful code. We've lost focus that we need to build code that lasts, code with a future. So I'm going to leave you with this. Gentleman on the left in this photo probably needs no introduction, right? He's the other co-founder of Apple, the other Steve, as it were. But it's really unfortunate that, in the large part at least, the guy on the right has been forgotten. That gentleman's name is Bill Atkinson. Bill was convinced to actually abandon his PhD program by Steve Jobs to come to Apple and make the Lisa. And he's still bitter about it, by the way. Bill is responsible for a lot of things that we just take for granted today. Bill created QuickDraw. That up until the early aughts was the only way that a Macintosh drew pixels on the screen. He independently discovered a math formula, the midpoint circle algorithm, that allows computers to draw very fast circles on the screen. And they still use it, by the way. He invented HyperCard, which was sort of the first low-code environment, if you want to call it, that very much so emulated what the web ended up being, probably 7 years ago. And he invented the menu bar at the top, MacDraw, the selection lasso, and he even invented double click. Seriously, he's that important in computer science. But that isn't why I've included this photo on here. I actually included it to tell you 2 stories. The first one is about Steve on the left and how important art is in code. The original Macintosh was not user serviceable, like at all. Like you had to make a concerted effort to open it as an end user. And even if you did open it, there was a CRT with a high voltage flyback right in the back of it, that if you ever opened up the original Macintosh and were not prepared for this and didn't know how to deal with it, it was probably the last thing you did in life. And so nobody ever really opened their Macs. And yet if you did, there was something wonderful and secret inside. The signatures of every person who worked on the creation of the original Macintosh is there inside the back of the case. And it's interesting because that back, as you can see it right now, no one would ever see. Steve Jobs was quite clear on why they did this. In fact, I've got his quote here. Artists sign their work. And even if no one, or at best few, would ever see those signatures, just like none of you, our customers and partners, will ever see our internal code, we should be proud enough of it to sign it. The second story I want to tell you is about Bill Atkinson on the right. So in 1982, Apple brought in a whole new series of managers, engineering managers, from a variety of different mainstream computer companies at the time. This was part of a whole move in Apple to, I guess the phrase was grow up in the early 80s. And those new engineering managers came up with a way to measure the progress and probably the relative worth of the software engineers on their teams by making them fill out a form every Friday so they could track them week by week. Included on that form was a field for number of lines of code that were written by that software engineer for the week. So Bill, and rightfully so, thought that this was a ridiculous metric to track, lines of code. In IBM, we even had a phrase for it, KLOCs. And by the way, I agree with him. It violates everything that we've discussed together in this session, everything that you heard from Richard and Chris yesterday morning. It doesn't make code with a future, does it? You know, at the time, Bill had been working on optimizing QuickDraw, that code that puts pixels on the screen of the Macintosh, and did so for almost 20 years. Code with a future, right? And so Bill was filling out his weekly form, and he got to that field, lines of code, and he sat there and he pondered it for a minute. And here's what he entered. Negative 2,000 lines of code. And that is what we are transforming to be. We're going to be the team of unique and well-applied how techniques, get the most out of our teams, get the most out of our products, bring more features, more functions, more capabilities to our customers faster, simpler, more elegant. We are going to build software with a future. We're going to be changing how and what we do things. And maybe, just maybe, we're going to start signing it as well. So enjoy the rest of the factory tour. Thank you very much for your time, and I'm sure we'll talk again soon.